Hello everyone, and welcome back to the Fluctus Channel. Gatling guns are the cornerstone of present-day military operations, possessing unexcelled firepower, functionality, and dependability. Launching a rapid-fire barrage in small bursts is important to suppress enemy forces and defend key positions. Its use brought an incredible amount of firepower to the battlefield. After a few decades, the Gatling-type guns were used on aircraft. First was the Lockheed F-1 Not-4 Starfighter, which mounted the M61 Vulcan cannon, a 6-barrel rotary cannon in 1959. By adapting the Gatling design to aircraft, fire was rampant and sustained. Aircraft could obliterate enemy humans on a continuous, stable basis. A new era of air-to-air and air-to-ground operations had begun. The GAU-8 Avenger is a 7-barrel, 30mm rotary cannon built around sheer stopping power. Developed for the A-10 Thunderbolt II, the aircraft was designed around its gun as a tank-killing weapon. The cannon fires armor-piercing incendiary rounds at a blistering rate, giving pilots the ability to engage armored columns with extreme precision. Its ammunition drum is integrated into the aircraft nose, and the recoil axis aligns with the fuselage to reduce airframe stress. The weapon uses a hydraulically driven Gatling-style mechanism with redundant systems for reliability in combat. Armor-piercing rounds punch through heavy armor, while high-explosive incendiary rounds defeat softer targets and start fires. Designers armored the gun and feed system and positioned fuel and systems to protect them from ground fire. Recoil forces are absorbed by the airframe, and landing gear was strengthened for operations from austere fields. In combat, the GAU-8 is paired with advanced targeting sights and stabilized pipper displays, allowing pilots to employ short bursts from low altitude with high first-shot kill probability. The result is a purpose-built platform centered on lethal, survivable, and surgically precise close air support. It remains iconic in close air support. GAU-8 maintenance is meticulous and safety critical. Certified armorers perform regular inspections of barrels, feed mechanisms, and the ammunition drum. And torque settings are verified. Feed assemblies and cartridges are inspected for cracks or corrosion. After maintenance, functional checks and controlled live fire verification confirm timing and reliability. Detailed logs document inspections, parts replaced, and test results. Strict handling procedures and training keep the Avenger mission ready and safe and documented. A 10-gun installation is a precise process centered on the GAU-8 Avenger, emphasizing rigorous safety. Technicians align the cannon along the aircraft's fuselage centerline. Recoil supports, structural fittings, and armor plates are checked to absorb firing forces. Feed chutes and links are secured, electrical and hydraulic drives are connected and tested. Bore sighting and timing ensure rounds exit with correct trajectory and firing rate. Covers and access panels remain open for final safety checks and quality assurance checks before operations. Final checks are documented to certify the gun for flight operations and combat employment. The Avenger cannon is loaded using the Universal Ammunition Loading System, a purpose-built ground support solution that speeds reloads while protecting crews and the aircraft. Trained armorers and ordnance specialists coordinate to transfer linked 30mm rounds from secure handling carts into the aircraft's integrated drum and feed assemblies. Safety and accountability drive every move. Weapons officers verify lot numbers, inspect links and projectiles for defects, and enforce strict handling rules. The loading process is performed under controlled environmental and safety conditions with quality control personnel standing by. After loading, technicians run non-invasive checks to confirm feed continuity and document serials and quantities in official logs. Regular training, rigorous procedures, and redundant inspections make sure the gun is mission-ready while minimizing risk to crew and airframe. The Universal Ammunition Loading System streamlines a complex task, but relies ultimately on disciplined people and uncompromising safety culture. Loading bombs and ordnance onto a 10-wing pylons is a tightly controlled operation carried out by certified ordnance crews. Aircraft are grounded and safety perimeters established, while teams verify load plans, compatibility, and munition serial numbers. Jammers raise stores to the pylon where technicians secure munitions, safety pins, and fittings. Multiple inspections confirm mechanical latches, electrical interfaces are engaged, and that the ever-present red remove before flight pins are in place. Pilots verify that the ordnance has been loaded on the aircraft properly before flight. In the constantly changing world of modern air warfare, filled with advanced technologies, fifth-generation fighter jets have become crucial as countries compete to control the skies. Among these, the F-35 stands out as a prime example of air power. Designed for missions ranging from high altitude to electronic warfare, the F-35 doesn't necessarily highlight today's transition to a versatile, all-weather, operational aircraft not only on many, but also represents a major advance in aviation technology. The F-35 represents the peak of stealth fighter technology, designed to minimize radar detection while maximizing combat performance. As the second fifth-generation fighter in U.S. service, it integrates advanced avionics and sensor fusion to offer exceptional situational awareness and long-range lethality. This design philosophy ensures it remains highly effective in suppressing enemy air defenses, as highlighted by the U.S. Air Force. Each model, from the F-35 Amperes to the F-35C, incorporates lessons from the F-22, optimizing aerodynamics and materials for reduced radar signature and enhanced durability, positioning the F-35 as a formidable asset in modern aerial combat. Stealth technology fundamentally changes the dynamics of modern combat and is designed to make an aircraft invisible to radar and other detection systems. The F-35 leverages this technology through several advanced features. The outer body of the aircraft is designed with sharp edges and specific geometric shapes that help decrease its radar cross-section by scattering and trapping radar waves rather than reflecting them back to the source. The aircraft is also coated with a radar-absorbent material that further diminishes its visibility to enemy sensors. The F-35's stealth capabilities are enhanced by internalizing critical components. Sensors, weapons, and fuel tanks are all housed within the aircraft's structure to maintain a sleek, non-reflective profile. This design minimizes its infrared signature by reducing the heat detected by enemy systems. Stealthy systems against radar and electromagnetic threats grant the F-35 a significant advantage. This makes the F-35 invisible. When examining the F-35's combat capabilities, the GAU-8 Avenger 25mm Gatling gun stands out as a compact powerhouse tailored to the jet's mission needs. Far from a generic cannon, the GAU-8 Avenger was developed specifically to interface with the F-35's weapon systems, giving pilots a high rate of fire in close engagement scenarios where precision and reliability matter most. At roughly 230 pounds, the gun adds relatively little mass compared with the lethality it provides, able to deliver up to 3,300 rounds per minute. That rate produces substantial recoil forces near 3,700 pounds, which designers mitigate through careful alignment with the airframe and robust mounting arrangements. The weapon can be driven by hydraulic, electric, or pneumatic power, and accepts multiple feed types depending on mission logistics and ground support equipment. Integrated fire control and targeting displays allow short, controlled bursts to maximize first-pass effectiveness while limiting ammunition expenditure. Routine maintenance, careful ammunition handling, and strict safety procedures keep the GAU-8 Avenger ready for action, making it a versatile and reliable close-range weapon for the F-35 across a wide spectrum of operations. In addition to its potent weapons, the F-35 features a highly advanced electro-optical targeting system, or EOTS, that elevates pilots' situational awareness and weapon accuracy. EOTS is the first system in the world to combine forward-looking infrared, or FLIR, with infrared search and tracking, or IRST, into a single package sensor. That fusion lets the aircraft generate clear thermal imagery day or night, automatically detect and track multiple targets, and provide precise laser range finding for guided weapons. Because the sensor is integrated into the aircraft fuselage beneath a scratch-resistant sapphire window, it preserves the jet's low observable shape and reduces aerodynamic drag while protecting sensitive optics. Pilots receive stabilized, high-resolution targeting video and cueing data directly to their helmet displays and mission computers, enabling quicker decision-making and more effective first-pass engagement. The sophisticated systems installed in the F-35 also contribute to its maintenance demands. With the annual budget for an individual aircraft running around $6 million. This high cost reflects the complexity and advanced technology that make the F-35 a formidable fighter, requiring specialized care and regular updates to maintain its operational readiness and technological edge. From the early Gatling guns that changed ground warfare, to the precision cannons mounted on today's stealth fighters, the evolution of automatic weapons has shaped the very nature of combat. What began as a manually cranked innovation now defines modern aerial dominance. That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.